First, let's talk about the situation that is called a statically determinate problem through analyzing a stepped bar. When a load is acting on an object, we firstly find the value of stress from the load, and then the strain from the stress. Finally, we use Hooke's law to find total elongation. Here, we can calculate the elongation from the strain. You may remember this sequence of calculation steps as a standard procedure to solve a statically determinate problem. The sequence to find stress from load, strain from stress, and then total elongation from strain. Now, we are firstly thinking about a stepped bar in tension as shown in the illustration. The stepped bar has round cross-section of different thicknesses. These two parts are completely attached to each other. You can imagine that this stepped bar has been carved out from a long round bar from uniform thickness to make the stepped part. We are now trying to calculate the total elongation of this stepped bar when P is applied to both ends of the bar. As previously mentioned, the stresses are all uniform in the cross-section, which means in the direction of width or thickness of the bar. In other words, we are solving the problem assuming that there is no stress disorder. We are starting with stress of the left portion of the bar. Stress is the load divided by the area of cross-section. For the section on the left, assuming that the cross-section area is A1, it is the square of D1 divided by 2 multiplied by pi. So, we get the stress by dividing the load P by pi D1 square divided by 4. The strain is then obtained by dividing the stress by Young's modulus. This is Hooke's law. From the formula sigma equal E epsilon, we calculate the strain. We get the result. Then, we calculate the elongation. Elongation, in the case of this problem, is generated from a uniform strain in the longitudinal direction. That is because the left and right sections have constant diameter, respectively. So, by multiplying the strain by the original length or the length of the bar, we get the elongation. So, now we have obtained the elongation on the left side of the stepped bar. As for the right section, it can be calculated in the same way. This is the part of the diameter T2. Stress can be calculated by dividing the load by the cross-section area. Finally, elongation can be calculated by multiplying the strain by the length of the right section. This is how we perform the calculation. At the end, you can add these elongations together to get the total elongation of the bar. I think it has not been difficult at all. It is a simple example of statically determinate problem. So, we firstly calculate stress from load, strain from stress, and elongation from strain. This is the calculation procedure to smoothly get the solutions.